It's nice and beautiful out here in New York. So yeah, nice day out. All right, perfect. With that, let's get started. So my name is Christopher Callis, and I'm head of cloud security over here at Tevora. Just want to give you all a little intro on what Tevora is, who it is, the things that we do, and then we'll dive into the topic at hand. So Tevora is an information security consulting company. We specialize in a whole bunch of different areas, whether it's the compliance side, we could pretty much certify against, pretty much any type of 3-letter requirements. We have your traditional threat side where we'll do, our penetration testing, red teaming type activities, incident response type stuff. So our IR team is PFI, which is a PCI forensic investigator. So that means if there is a breach, there's credit card data involved, there's a small list of folks that are certified to go in, actually do the investigation and, really get to the bottom of what actually occurred. We have our solutions side that specializes in a subset of, really tools that we enjoy using with our workloads, and they were really good at getting those implemented and working with them. And we have the cloud security side, which is all about cloud security and making sure your workloads are secure and making sure that they meet your compliance requirements as well. So with that said, let's get started, and then we'll save any of the questions. I think there's a little question button on GoToWebinar. It's been a while since I've used this platform, but if you guys do have questions, we could do polls too. So maybe I'll throw a question out there. Feel free to put it in there, and we'll have a little Q&A at the end, and I'll provide my contact details for those of you that are shy and want to go down that route. Anyways, let's get started. So good afternoon or morning, depending on where you are at. My name is Christopher Callis, and I'm head of cloud security over at Tevora. Today, we're going to be talking Azure security best practices, and the ways we have helped organizations be successful in achieving their security initiatives while using Azure. When it comes to Azure, we have found adoption trends on the slower side of things compared to other providers such as GCP or AWS. This is important to consider before you decide to solely implement your workload within Azure. One of the biggest reasons behind this is most likely due to the management control plane. At the moment, Azure does not give you the same level of control via API as AWS or GCP. This has, however, been a focus for Azure over the last, I'd say, year or two. Organizations want to scale their workloads. They want to industrialize their application delivery process across each layer of the cloud. The best way to do this is via declarative, mutable architecture, also known as everything as code. In this model, infrastructure, applications, storage, services, or security settings, everything else that you can think of should be defined as code. Being immutable means it can be torn down, upgraded without fear of data loss or outages. Being declarative means everyone is speaking the same language. This means that build times are drastically reduced and confidence in the workload increases. Teams spend less time worrying about the what ifs and can focus on pushing the architecture boundaries. With that said, it's inevitable that organizations spread their risk across multiple cloud service providers. But how this is being done may surprise you. Instead of having these single, separate, isolated environments that are not uniformly configured, we are finding organizations embrace the multi-cloud self-service model in the way of providing a pool of compute capacity on demand spread out across multiple cloud service providers. With this, we need to understand the baseline, and that means cloud service providers' capabilities, what could be standardized, and the manual effort involved. Today, we're going to focus on Azure. So when it comes to Azure, there are a couple common, misconfigurations that we constantly find. We're going to review these misconfigurations, what they mean, their secure values, and understand if we could implement the control as code or if it needs to still be a manual type process. This is going to be a hybrid presentation / live demo, so we know that those always work out pretty well, but hey, I've codified most of it, so we shall see what happens. Perfect. To start, let's discuss Azure Managed Security Defaults. Azure does a really great job at enabling a lot of security by default. These default security settings, which are found under the Azure Active Directory properties, the managed security defaults, we'll take a look at it in just a second. They're going to implement some great defaults, such as requiring multi-factor for all users, require admins to perform MFA authentication, blocking things like legacy authentication protocols. They require users to perform MFA when necessary, and they protect privileged activities like access to Azure portal. Note, there is a lot of MFA in there. Are you guys surprised? Do you have an MFA enabled? The answer probably may surprise you. A way that I like to test this is have an administrator authenticate to the Azure console on a corporate network. Are they presented or interrogated with an MFA prompt? From my experience, the answer is generally no. We find corporate networks are generally whitelisted from having to provide MFA. We strongly recommend any auth into Azure has MFA enabled and enforced, especially the right type activities. Without this, browser sessions could be compromised and others may be able to access the control plane. It's something common we see our threat team do during penetration tests. So let's take a look here for just a second. So to take a look at the security defaults here, what we want to do is take a look at Azure Active Directory. And then we take a look at security settings. We're going to bring conditional access up in just a moment. Next thing we're going to do is we're going to go to properties. And then when we do manage security defaults, you're going to see right here, this is the enable security defaults section. That's the part that requires all users to use MFA, block admin. We'll link a K-Base article from Microsoft that goes over all the particulars that this does. So you may be wondering why my security defaults are turned off after I've told everybody to leave them on. Well, if you really want to get granular with it and really start, enforcing a lot of granular policies, which I'm going to show you here, what I like to do is I like to set conditional access policies. And I did a YouTube video on this a little bit ago, which we're going to link at the very end for everyone to do. But you could see here, if you do generally apply these conditional access policies, it requires you to turn off these security defaults. And I'm generally finding, with a lot of assessments that this is something that is turned off. But then I don't see these conditional access policies to layer in the controls that security defaults provides. So a couple of policies that we discussed here, and again, you could take a look at the YouTube videos we have to kind of learn how to implement these, but we have a multi-factor policy, which requires everybody to use multi-factor across, every, whether it's via the console, the CLI, they're logging into Office 365, those type of things. I have it set to block legacy authentication, and then I also implemented some region blocking going on here. So yeah, for more, again, take a look at the YouTube video, but we'll move on here right now. There I am. Perfect. Just making sure we're on the right slide here. Next thing we want to do after we talk about the security defaults is talk about programmatic access. More importantly, human and programmatic access, and the best ways to actually control that access. So the next common security misconfiguration that we find is how human versus programmatic access is actually handled. Humans are generally, from what we find, overprivileged, and programmatic access and the keys that are associated with them are generally long-lived. Because of this, we recommend one of two solutions for managing programmatic access. One, define a service principal with either a client certificate or a client secret, or even better, use a managed service identity. So if you go down the service principal route, ensure that the certificate or the secrets are protected and not used in the configurations used to provision your environment. We'll take a look at those configurations and how I like to use them in just a moment. On between the service principal or the managed service principal side of the house, I really like to use the managed service identity to grant programmatic access because that generally eliminates the secrets from applications altogether. But my favorite way of managing secrets is using technologies such as like HashiCorp Vault. So instead of creating multiple service principals and having to track those long-lived keys, instead, applications will authenticate to Vault, and they are issued short-term credentials that generally expire within the hour. This technology is great because it's supported across all cloud service providers. It has been a favorite way to manage programmatic as well as human access of our clients to manage their environments. Note on the human side of the house, it's important to ensure things like global administrator are just not assigned to everybody. Azure Active Directory provides some great default roles that allow users to do what they need to do for a given job function. This, coupled with monitoring of audit logs, allows you to really tune those policies or implement things like just-in-time access, ensures users are never over-provisioned. So just to kind of give you guys an example of how I like to do this, let's flip back to my browser here. And if we take a look at Azure Active Directory and we take a look at the application registrations that I have, you could see that I use Terraform Cloud. And I use Terraform to provision the entire pretty much infrastructure. Everything that we are allowed to do within Azure Active Directory, that's what we're actually provisioning. So when you generate, this application here itself, it's going to give you the app ID, the tenant ID, but it's also going to give you, if you take a look at certificates and secrets, it's going to give you a secret itself that expires 6/15/2021. You could get granular, but again, I like to automate that side of the house, and that's where that HashiCorp Vault really comes into play. But now if we flip over to Terraform Cloud here, which is what I'm using, this is the workspace that we are using for this actual webinar. And within the workspace itself, we could take a look at the variables, and we could see things like the Azure subscription ID, which I showed you guys here. Azure ID, the client ID are all defined, but those aren't really sensitive variables. The things that do become sensitive variables are admin passwords, for example. This is a password, since we didn't get super advanced with how we're actually managing the secrets. This is the password that's going to get provisioned to establish the password across all of the virtual machines that are going to get spun up during this exercise. And then right here, this is the service principal secrets. And what's nice within Terraform Cloud, and I think the regular Terraform environment, is you could see that the values are set as sensitive write only. That means I can't go in there if I wanted. And let's see if I can move the go to webinar out of the way so I can show you guys. So it only lets, if I go to edit, the values write only. So there's no way for me to actually view what the value is here. It doesn't show up in the outputs when you actually run Terraform. It's really great. The only thing that it falls short on is really rotation of those the keys on a periodic basis. That becomes a manual activity. And that's where something like HashiCorp Vault is great to allow this to authenticate into Vault. And Vault will provide a short-term credential that's specifically allowed for this application to provision the environments. And just in case there is a compromise between the copy and paste or the generation, that credentialing lives for an hour before it's done. So things to keep in mind, when you are setting these things up. It's really, really common for us to find hard-coded credentials within the environment variables. There's also things more on the AWS side, like using parameter store. And Azure has the same type of functionality within Vault itself. But again, the permissions that surround it, we don't generally see resource locks and stuff like that put in place on the Azure side. And it's really easy to enumerate those values out of Vault itself, just because a lot of the accounts are overprivileged. Something like this, even though I'm the full administrator within Terraform Cloud, I have no access to, which is awesome. All right, moving on. Live demo is working okay so far. Next thing we're going to talk about are network security groups. And I'm going to grab a little bit of water. So another item that we see commonly misconfigured are network security groups, or NSGs. NSGs provide a way to filter network traffic to and from Azure resources. The most common thing we see with NSGs are default security policies. Remember, it's important to specify the port, the protocol, and the expected source and destination traffic. We'll take a look at an NSG example here in just a moment, where we'll see that it is actually overprivileged, and then we're going to lock it down to a particular IP address or CIDR block. That way, we're only allowing, our SSH or RDP access over, allowing it in over only specific whitelisted IPs. So let's take a look at that really quick. So we're going to go back into the Azure console here. We're going to take a look at the resource group that has been spun up for this lab, and we're going to take a look at one of the network security groups. Let's be at the SSH security group. So what we can see here, and this is something we commonly run into, and this is really important to really nail down earlier. We always get into conversations when we're reviewing these things like, hey, we'll lock it down later. But generally, pre-production mirrors production, right? And this is the best time to really, do all the smoke testing or whatever you need to do to get your environment really tuned in and making sure that your pre-production accurately reflects what's actually going to happen in production. Since a lot of the times, especially when you're using, infrastructure as code or everything as code and, declaring these things, if one works in one, it should be working in the other. So here's an example of, we're seeing the security group webinar SSH security group over port 22. So it's for SSH. One of the items that we see here commonly being misconfigured is instead of port 22, we'll get a bunch of ports here. The restrictions, how many inbound and outbound security rules are pretty lenient. So you can add them. There's no reason to kind of bundle in multiple ports and protocols in a single security group. Definitely break those out. Source and destination address. Hey, where should my traffic be coming from? That should be definitely defined. And the destination. Hey, where do we want this traffic to go? If we're hitting a bastion host, we want them to land at the DMZ. Then from the DMZ, there would ideally be a security group that allows it administrative access to whatever it is, in your public or your private subnets. So this doesn't look right. Okay, so the one thing that we're going to do here is we are going to update. Just flip over to the code really quick. Don't worry, this isn't too overwhelming. We talked a little bit about immutable and declarative architecture. So, Azure has their configs, and you could see it on the right-hand side. I'm using Terraform, which is declarative and allows our environments to be immutable. What declarative means is exactly this. So this 56 lines here, and that's not really even being efficient, that's just something quickly thrown together, defines the network, the CIDR range, both of the subnets, and it starts going into the security groups here. On the, the default exported templates that come from Azure here, this takes to define 104 lines versus 55. The other thing that you can see here is there's really a lot of, these default values, these hard-coded values that aren't going to be the same across all your different environments. So it makes it really hard to replicate and scale your environments in order to be consistent from one subscription, one environment to another, right? So one thing I'm going to update here is here's our SSH security group itself. And we're going to update the source address to Google's DNS server. I don't know if anybody's going to be coming in from there, so we're going to save it. Then I'm going to commit it. And I'm going to push. And what we're going to do here is we're going to go back to demo. And then what we should start seeing here is automatically it pulled the update from GitLab itself into the appropriate workspace. And it's starting to provision the run. And let's take a look at what it does here automatically. So all I had to do was save and push. Ideally, there would be some type of pipeline process that requires an approval. But let's just imagine, that's going through. So right now we can see that there's one thing to change. And we could tell that it has to do with the Azure security group itself. So next step that I have here is it's going to go into cost estimation, just because, expensive costs are definitely a thing that exist. So we'll wait for that to finish, which it's finished. And then we're going to confirm and we're going to apply, which means it's going to push that out now to Azure itself. And the apply is going to run. And it should just take a minute. Hey, our live demo worked. So now if we go over to Azure and we refresh this page, let's move this thing away. We're going to refresh the Azure page. And boom, now we can see that source back to 8.8.8.8, which is what we just defined as code. So that's really cool. And that kind of gives you, the ability to see, when doing things as code and why it's so important. Because if you could define all of these variables, you can replicate this across every single subscription, because it's never just one subscription or VPC. We see clients scale up to hundreds and thousands of them and really want to be able to provide the capability on demand with a secure environment. So let the developers and the operators do what they need to do and really define and bring security up to the code level to really make sure that they're enforcing the change. And we're going to talk about that a little bit here in just a moment. So we're going to go back to the presentation. This is working out pretty cool. So I'm pretty amped on it. I don't know if you guys can tell. But let's keep on going here. So the next thing I want to talk to everybody about here is a little remote network security groups. So right here. So another thing to check is to ensure that secure, we talked about the network security groups themselves. Okay, secure transfer. There we go. That's the slide that I was looking for. So another thing to check is ensuring secure transfer is enabled for storage accounts. This enhances security of a storage account by only allowing requests to the storage account by a secure connection. This is enabled by default when we define a storage account within the Terraform configuration, and this is how you can audit it. And what's great, actually, when I was putting together this presentation, I think it's a new thing. It's not a new thing. I dug into it, and Terraform implemented it a little bit ago, but it's not even reflected in the literature with Terraform, which was pretty neat to see, because this is something that we run into quite a bit. So, oh yeah, let me flip over to the live demo itself, which has gone pretty smooth, knock on wood. So we want to take a look at the storage account here. So here's the storage account that is actually created, and we're going to go to configuration. And what you can see here is secure transfer is enabled. So we'll flip back to the configuration I had in just a moment, but just by establishing storage accounts, it looks like enables secure transfer. But with that said, secure transfer is one of those things that we see very sporadically enabled or disabled, and it's generally for some type of troubleshooting. And there's not really a lot of, even security policies that exist since I've last checked that really would alert you if secure transfer gets disabled. And if secure transfer gets disabled, that means, you potentially have sensitive values or configurations, customer sensitive type stuff getting written over an insecure channel, which means you could be getting man in the middle, right? And then storing something that could be malicious. So it's definitely one of those things that you want to keep an eye of and ensure that that is actually enabled. And a great way to do that is to define here, code here, define the actual storage accounts as code. And you could see here, I have enabled a storage account called ATP, which is used for the Azure Advanced Threat Protection, which I turned on as code. You can see that there's nothing in there of me specifying, to use secure transfer. It's just done by default, which is pretty cool because I spent a little time putting this together. And I'm like, why can't I turn this on? Something used to kind of exist or whatever, and I'm reading that it works, and I should have just checked the configuration on my end. So lesson learned, but it's an event. You guys get to reap the rewards of that, clarity. So yeah, secure transfer is great. Next thing that we're going to want to talk about is audit logging. So as we all know, logging and auditing is important. It's no secret. It's something that's been around for a very, very long time. Even if you go back to the old DoD Rainbow books, you could see them talk about the importance of actual auditing of the systems and the applications that run. And that's back in the 80s. And things have only gotten more complex since. So with the cloud, it's really vital to ensure that you guys are capturing, administrative actions across the cloud control plane, both from, a web console as well as the CLI. The other thing that I like to do is really break down all the technology components that are being leveraged and ensure that those logs are getting offloaded into your SIEM of choice. For example, if you're using a managed database instance, if we take a look at the activity logs here within the resource group, we can see everything that's occurring in here, whether it's updating policy, rolling a policy back, failure during the creation of a virtual machine a little bit ago. It's logging everything, but it's not giving us things that are actually happening on systems. If I SSH into this virtual machine and I start sudoing all over the place, it's not going to capture any of those administrative actions, which is something that you really want to actually be capturing. And the same thing goes for managed services themselves. It's really important to read roles and responsibilities, regardless of whatever cloud service provider that you're using, and ensure that you are adhering to those. And a lot of the times, especially with stuff like managed databases or things that transform data, there's audit activity that gets generated. So it's important to be offloading that, into your SIEM of choice. I like this little laser thing on the presenter. It's pretty neat. So yes, capture cloud control plane. Make sure you guys are breaking down all the technology components and are capturing everything is really what you want to take away from this. So when we talk about managing complexity of the controls, a lot of these things could become overwhelming, especially as you span to multiple cloud service providers and have hundreds or thousands of accounts within each. To help manage this complexity, I like to do two things, maybe three things. Break down the complexity and map out each of the components and get an understanding of what can be automated and what can. Like we saw with Terraform, we know we could automate the networking side of the house, the actual, a lot of the components of the actual Azure subscription. We could start defining, service principals. We can make sure that storage accounts are enabled, and because they're enabled, we could see that, secure transfers are actually enabled. There's a lot of things that we can do within Azure, which is really just, shows you the type of work that's been done over the last year or two in order to provide that capability with industry standard tool sets, which is great to see. So I like to use Terraform since it allows me to really use infrastructure as code to provision and manage my cloud infrastructure, the services, and everything that are a part of it. It allows me to really design this self-service, secure, and compliant modules for my clients that allow for the consumption of a particular network, an application stack, or a cloud service at the click of a button. For things that Terraform does not do or does not do well, we layer in really configuration management tools such as Salt, Ansible, or Chef. This allows me to define things like my virtual machines, ensuring consistent hardening standards are applied, and really, those gold images for business units to consume and really layer in whatever else they need on top of that. So after we figure out what we can automate, we then layer in the governance to the cloud to enforce these types of controls. On AWS, I like to use some native controls like guardrails mixed with organizations to prevent things like IAM changes, enforce encrypted buckets, and especially if it's a PCI environment, making sure there's sanity checks done to ensure that the environment is compliant and doesn't deviate from that. Some clients like it set up so it's like it will not let an organization, once it's onboarded and being monitored, to deviate from it at all, which is nice generally, and it doesn't cause as much headaches as one would initially think, which is pretty cool to see how far that has come along. So Azure is still really maturing in that sense. So I like to leverage things like Sentinel policy on the Terraform side. With Sentinel policy, we can do things like specify what type of, virtual machine that we want to allow our developers to use. That's important because, hey, there's some really big ones in there that take up a lot of compute, and, instead of like $10 a month can cost you thousands of dollars a month. So put those stops in right in place. We like to check for things like making sure credentials aren't hard-coded. Making sure that the security groups are defined as we expect and don't just have any everywhere. So there's a lot of really neat stuff we could do with Sentinel policy. And I do like to bring security teams even further up to the stack, depending on what type of, Git repository is actually being used. So if you're using something like GitLab, I like to integrate them into like the CI/CD process and make sure the governance is applied at that layer before it even hits Terraform, which is a lot of fun. So we talked about Sentinel policy. The other thing that I like to do is layer in activity log alerts on the Azure side for critical activities, such as changing a security group, modifying policy assignments, updating or deleting SQL Server firewalls, and so on. This allows me to implement triggers on the SIEM so our security teams, or our client security teams, know to respond to a critical type of event. Anything else in Azure then I'll leverage export templates. I try to stay away from these, like we discussed earlier, just because they're way more complicated. People aren't speaking the same language, and generally once it falls back to the export template side of the house, we just see configs kind of go all over the place. So use them, but it requires a lot more training and a lot more control around it. But if it's the only thing that exists, it's better than going through and manually configuring secure transfer across 100 accounts. That's me. Perfect. All right. So during the webinar, we discussed managing complexity in the cloud, talked about common security misconfigurations with Azure, how to manage secure configurations with automation. So as you may have gathered, leveraging code is important. This is the future for security and compliance teams alike. Moving security to the CI/CD phase of the house really reduces your release time, automation, and security testing, ensure compliance and security requirements are met early on. And then layering governance such as Sentinel policy, guardrails, and so on, ensure that environments stay compliant and do not drift. I really appreciate you all joining today. Contact details are on the screen, and feel free to check out our videos on the YouTube. I haven't gotten to the point where we get like a dedicated URL for YouTube, but if you search Tevora Cloud Security or my name, you'll find a lot of content on there, and more content's coming along.